Hey guys, so we're moving on to the next unit and the next set of notes. So unit 8 is all about probability and statistics. So I'm going to teach you the first thing about probability, and that's the counting principle, okay? So the counting principle in probability is a way to find out how many options or how many possibilities there are. So what you're really trying to do is you're going to be given a Venn diagram and you have to figure out the total possible outcomes for the Venn diagram completely. So in order to do that, according to the counting principle, what you have to do is you have to count how many options there are. So it says a class is choosing a president, a vice president, and a treasurer. Find the total number of outcomes given the following. So the information that it gives us is it says there are 2 students that are running for president. There are 3 students who are running for vice president. And then there are an additional 2 students running for treasurer, okay? So when we figure out how many possible outcomes there are, all we're doing is we're writing down how many options there are for each of the president, vice president, and treasurer. So the president we said was 2, so we write 2 here. The vice president was 3 options. And the treasurer was 2 options. So we're going to say 2 times 3 times 2 is 12, and that's the total number of possible outcomes. And you'll see in the Venn diagram, if you count how many possible outcomes there could be, then there is 12 listed all the way to the right. So that's the counting principle. So now you try. In the next one, it says the lunch special at Chris's restaurant is a sandwich, a drink, and dessert. So out of those, there are 3 sandwiches to choose from, 1 drink to choose from, and 3 desserts to choose from. How many specials are possible? So again, we're going to take those 3 options and we're going to multiply them. So we've got 3 sandwiches times 1 drink times 3 desserts. So 3 times 1 times 3 is 9 total possible specials that you could do. And says when ordering the kids' lunch, this is how many there are. So now you're going to be given a diagram, and now you actually have to count how many choices there are for each of the options and then multiply them out. So in the first one, we have for size, there are 2 choices, small or large. For the type of bun, there are also 2 choices, white or wheat. For the side order, there are 3 choices, fries, onion rings, or a fruit cup. And for the fruit drink, there are 4 choices, orange, grape, cherry, or lemonade. So we're going to take those 4 different choices and multiply them together. So 2 times 2 times 3 times 4 is 2 times 2 is 4, 4 times 3 is 12, and 12 times 4 is 48. So our final answer here would be 48 possible lunch options. Okay, so that's the counting principle. So moving on, we're going to talk about probability in general. So whenever you're talking about the probability of something, an easy way to remember the probability of something is want what you want over the total. So this is the easiest way right up here to remember something when you're doing probability. What is it that you want over the total number of possibilities? Okay, so let's talk about a bag with 10 marbles like they have here. They want, they're asking you, what is the probability that the marble that you pick out will be right? And you write it as a fraction. So again, what we want is how many white marbles there are out of the total number of marbles that are in the bag. Okay, so that tells me my probability. So if I look at here, I have 2 white in the bag over 10 total marbles. So our final answer in reduced form or simplest form for a fraction would be 1/5. So the probability of choosing a white would be 1/5, what you want over the total. In the same sort of problem, we have a bag with 6 marbles, and they want the probability that the bag is gray. That the marble is gray when you pick it out. So again, we're doing gray over the total because gray is what we want. Oh, sorry, didn't mean to put white. We're doing gray over the total because gray is what we want. So how many grays are in the bag? There are 2 grays in the bag over how many total marbles in the bag? 6 total marbles in the bag. So that can be reduced to 1/3. So the probability of choosing a gray is 1/3. Okay? Then you're going to get given a different type of problem that's kind of talks about, it's still probability, and it's talking about the probability of flipping a coin, whether it lands on heads or tails. So what you're going to do is that this time, this time they give you all of the possible outcomes for flipping the coin 3 times, okay? And they want you to check off which ones have these certain events, okay? So if we look at the first event says a head on the last toss. So we're going to go ahead and check all the ones that have a head on the last toss. So the first one has a tail, second one has a head on the last toss, so I'll check that one off. Third one doesn't, fourth one doesn't, fifth one doesn't, sixth one has a head on the last toss, the seventh one has a head on the last toss, and the last one has a head on the last toss. And then what you want to do is you want to make the probability for those by making it into a fraction. Notice that the total outcomes here is 8. There are 8 total outcomes, so we're going to make all of our fractions over 8. So the probability of this is I checked off 4 boxes out of 8 total outcomes. So my final answer would be 4 out of 8, which is 1/2 for that first row. Then we look at the second event and we do the same thing. So now the second event wants alternating heads and tails and heads with either coming first. So we're going to look at check off the only ones that are alternating. So if we look, the second one goes heads, tails, heads, that's alternating. The fourth one goes tails, heads, tails, and that's alternating. And all the rest don't alternate. So that tells me that I have 2 out of 8, which reduces to 1/4 for a probability. And then the last event says which ones have exactly one tail. So if you look, the second one has 2 heads and a tail. The third one has 2 heads and a tail. And it looks like the seventh one has 2 heads and a tail. So when I make my fraction for this, I checked off 3 boxes out of 8. So my probability for the last one is 3/8. So this is just a matter of checking them off and then writing the probability. And then the last one in this particular practice is going to be probabilities with 2 dice or 2 die. So what you're going to be given every single time is this nice little chart over here. And this chart shows you, what the sums are when you roll 2 dice at the same time. So for example, when you get a 1 and a 1, then the sum on the inside is 2. So this is called the sum chart, okay, for the dice. So when they are going to ask for 2 events, you're going to use this chart to calculate what the probability of those events are. So for example, the first one says, event A says they want the sums that are greater than 7. Again, this is the sum chart, okay? So that means all of those numbers on the inside are sums. So we're just going to count how many of the sums are greater than 7. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I again counted all the numbers that were greater than 7. So I found that 15 out of the total here is always in this chart 36. Okay, so the total is always 36. So my fraction becomes 15 out of 36 is the probability that the sum is greater than 7 when you roll 2 die or 2 dice. Okay, and you do not have to reduce that. If you can reduce it, you are more than happy to, but Alex will accept it as non-reduced fraction. Okay. The second one is the probability that the sum is not divisible by 4. So we have to mark off all the numbers in our chart that are not divisible by 4. So 2 can't be divided by 4. 3 can't be divided by 4. 5 can't be divided by 4. 6 can't be divided by 4. 7 can't be divided by 4. 8 can. 9 can't be divided by 4. 10 can't be divided by 4 nicely, and 11 can't be divided by 4. So if I go ahead and count all of the blues, I will have my probability. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So my final answer here would be 27 out of 36. Okay? And then in the U try, we try it again. So again, you either want to highlight or mark on a dice chart what it is that you want, so that way you can count it. So if we do the first event for this one, the first event for this is that the sums that are less than 6. So again, we're doing the sums less than 6. So if I go ahead and mark those off, let me get rid of that blue. In red, I'm going to mark off the sums less than 6. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And those are the only ones that are less than 6. So my probability would be 10 out of 36. Again, you can reduce that or you can just leave it. And then the second one is the event that the sum is divisible by 3. So now we got to think about all the ones that can be divided by 3. So 2, 3 can be divided by 3. 6 can be divided by 3. 9 can be divided by 3. And 12 can be divided by 3. So if I go ahead and count all those blues, I should get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 12 out of 36. Okay? So take your time with these ones and make sure you use that dice chart. You will always be given that dice chart, even on the test. All right, let me know if you have any questions. Good luck.